Hello everyone, this is Sangeeta, Assistant Professor ECE Department, SNS College of Technology. So today we are going to discuss about clamper. So the outline of this session is based on design thinking. The first stage is empathy, that is why we need clamper, and defining the clamper and ideate different types of clamper circuits. So before going to the topic, let us have a small recap about the previous session. In the previous session, we discussed about the clipper. The clipper is also one of the wave shaping circuit. So in the clipper, the output waveform is modified based on the desired shape of the input. So there are two types of clipper circuit, positive clipper and negative clipper. So in positive clipper, the positive side of the input waveform is clipped, that is removed, and in the negative clipper, the negative side of the input waveform is removed based on the reference voltage. So with this, we are move on to the topic, that is the first stage is empathy, that is why we need clamper. So we need clamper to improve signal compatibility and mainly to protect circuits from high voltage damage. And the other points are to shift the DC level and to add DC level. And it is mainly used in communication systems. So with these points, we can define what is clamper. A clamper circuit is designed to add DC level to the AC signal, that is shifting the entire signal waveform either in upward direction or downward direction. A clamper shifts an input signal by an amount defined by an independent voltage source. So it consists of diodes, capacitors, and the main application is that is the communication system. And the ideate part is there are different types of clampers, that is positive clamper, negative clamper, and biased clamper. So in positive clamper circuit, the input signal to the positive level, that is DC level, is above the zero level, and in negative clamper circuit, the input to the negative level is, that is below the zero level. And biased clampers, a biased clamper allows the waveform to be shifted above or below a DC reference, that is here in biased clampers we use reference voltage level. And this is the circuit, that is positive clamper circuit, and in this the main components are a capacitor, diode, and resistors. Here this is the input waveform, and here the output waveform. So the input waveform consists both the positive side and negative side. And here this is the reference, that is zero level, and for positive the entire input waveform is shifted to upward direction, that is above zero level. Okay, so the main working principle of the clamper circuit is during since it is a positive clamper, so during the negative cycle of the input waveform, the capacitor C gets charged and the diode D is on. So during this time the diode D is on, and it provides a path for the capacitor to charge. And the capacitor, after the capacitor is fully charged, it stores the energy. And during the positive half cycle, the diode is off condition, and this time the stored energy in the capacitor is added to the input. So the added charge and the input waveform shifts the input waveform to the upward direction. So this is the working principle of the positive clamper. And that is output is equal to Vi, that is the input voltage, and Vm, that is the capacity, the charge, that is the voltage stored in the capacitor. And this is the negative clamper circuit, and the same principle applies, but in the negative clamper circuit, during the positive half cycle, the capacitor C is charged and the diode D1 is uh, conducting. So that is during the positive half cycle, that is during the positive half cycle, the capacitor G charged, and it stores the energy, and during the negative half cycle, the charged energy is added to the input signal, and it shifts the input waveform to the negative side. And the next one is different types of applications, that is communication systems, and ADC, that is analog to digital conversion, the main applications of um, clamper circuit. It aligns video and signals for proper transmission in TV and communication system, and it limits the voltage spikes to the components for ADCs, and provide a DC offset for transistor biasing operational amplifier circuit. So these are the some applications of clamper. So hope this video will help you to understand what is clamper, and the working principle of clamper, and different types of clamper circuits and the applications. Thank you.